Hello everybody, welcome to Dr.K.Liu Math channel. And this question is from DSE M2, and it is the problem of integration. And integrate this function integrates 0 to power of 2 tangent to the power 2n x dx, and prove this identity actually equal to this one. And I think it is better to use mathematical induction. Let S and be the statement. Integration from 0 to pi over 2 tangent 2n x dx equal to summation k from 1 to n negative 1 to the power n minus k over 2k minus 1 plus minus 1 to the power n times pi over 2. Okay, and then for n equal to 1, we actually we have to integrate tangent square x. This is, and let me see, we have this identity. Tangent square is equal to secant square x minus 1 dx. This is tangent x minus x. When put the x equal to power 4, it is equal to 1, and minus pi over 2. It is equal to, let me see, summation k from 1 to 1. And negative, I think it is better to use this one, right hand side, not left hand side, and not because it is too abstract for students to understand the structure here. Summation k from 1 to 1, and it is 1 minus k, 2k minus 1. Yes, plus negative 1 to the power 1 pi over 2, 4. Oh yes, when put the equal to 1, 1 minus 1 is equal to 0. Negative 1 to the power 0 is 1, and it is 1. Oh, equal. They are equal. So great. Therefore, S1 is 2. Then for for assume SP is 2. That is, I think I better copy this one. It's true. That is the summation, the integration of tangent 2 to the power p equal to summation k from 1 to p, and this negative 1 to the power p minus k, or pk. So great, pk. Okay, for sp plus 1, this is tangent 2p plus 2 x dx. Here I think it is better to deal with this one is tangent to the power p x times tangent square x dx, and change the tangent square to secant square minus 1. And then this is tangent square px secant square x dx minus 10 integration pi over 0 to power over 4 tangent 2p x dx. By assumption, the second part is equal to this one. The first part can be integration by substitution, and group them together is this tangent, d tangent. Then this is equal to 1 over 2 to the power p at 1 over 2p plus 1 tangent to the power 2p plus 1x. And here I move the negative sign inside the bracket here. Therefore, the summation sign can be changed to p, summation p from k from 1 to p, and negative 1 is p plus 1 minus k, 2k plus 1. And this is plus 2, negative 1 to the power p plus 1. And finally, put this into the equation. It's 1 over 2p plus 1. And the second, this is equal to, yeah. Next step, I try to combine these two terms together so that it can be form a summation sign. And I think it is, I change this one and negative 1p plus 1 minus p plus 1. It is, and the denominator is 2p plus 1. Then these two parts can be combined together, form a summation sign. That is summation k from 1 to p plus 1 minus negative 1 to the power p plus 1 minus k over 2k minus 1 plus negative 1 to the power p plus 1 times pi over 4. That is the, actually the sp plus 1 is true. By MI, mathematical induction, Sn is true for all n. So great. That is the proof of this identity. I think it's something like that reduction formula, and we can use reduction formula to prove this one. But for DSE M2 student, it's better to use mathematical induction. Okay. Bye-bye.